welcome to Learn Miss. It's me, Linos. I hope you guys are doing very well. In today's video, we are going to discuss the most repeated 10 MCQs questions. Okay, so make sure you stay till the end of the video. Okay, yes. So now let's get started. Moving to the first question. Which one of the following first row transition elements is expected to have the highest third ionization enthalpy? Okay, that is the first question. Iron is given, then manganese, chromium, and vanadium. Okay, first you have to understand what is third ionization enthalpy. Okay, that is if you already removed 2 electrons. Now we are going to remove the third electron. Okay, so in the case of iron, iron is 26, right? So 3d6 4s2. If it is Fe2 plus, what will happen? It is 3d6. Okay, yes. Then manganese, it is 3d5 4s2. Mn2 plus means what? Mn2 plus means 3d5. That is, this is already half filled. So this is having what? Extra stability. Okay, note on that point. Then chromium 24, its configuration is 3d5 4s1, exceptional case. And if it is Cr2 plus means it is in 3d4 oxidation state. Okay, then vanadium 3d3 4s2. Vanadium 2 plus means 3d3. Okay, so when you write this, it is crystal clear that manganese is having highest third ionization enthalpy, because in order to remove another electron and to make it Mn3 plus, you have to apply high energy because it is already in the stable state, half filled state. Okay, yes, so this is the answer first question. Move to the second question. For an electrolyte undergoing association in a solvent, Van der factor. So we have studied about association and dissociation. Okay, yes. So what is Van der factor? Van der factor, it is a correction factor, right? It's a correction factor. So that will make us understand about the extent of association and dissociation. It is denoted by the letter I, small letter I. Okay. So how will you find this? I is equal to number of moles after association or dissociation, or dissociation by number of moles before association or dissociation. Okay, when a compound dissociates, what will happen? Compound undergoing dissociation, the number of particles increases, right? Dissociation means what? Number of particles increases. So what will happen? I value will be greater than 1. Okay, and if it is association, what will happen? If it is association, number of particles decreases and I value will be less than 1. Okay, so that is as one half factor. Association, dissociation, it is a correction factor. Okay, it depends on what? It depends on the number of moles after association or dissociation by number of moles before association or dissociation. And for dissociation, I value will be always greater than 1, and for association it is always less than 1. Okay, very important question. Moving to the next question. For the reaction X plus 2y giving T, the differential form equation of the rate law. So how we are finding the rate law equation, differential equation? So this is our equation given X plus 2y gives P, right? X plus 2y gives P. Rate of formation of P and rate of consumption of X and Y. Okay, how will you write the differential equation? Since the X and Y are decreasing, it will become minus d by dt of concentration of X. That will be equal to minus, here 2 is there, so it will become 1 by 2 d by dt of concentration of Y. That is equal to formation of P, that is plus d by dt of concentration of P. Okay, now just go through all this equation. You will understand which one is correct. Okay, in terms of P and Y, P first option, P and Y. Okay, and 2 will go to this side. Okay, and yeah, this is correct. Okay, no, checking the other. If you want, you can check the other options. Yeah, this 2 is taken to this side. So this equation is here. Okay, so this is the first one is the answer. Next, acetic acid react with PCl5. Very simple question. CH3COOH. Acid react with PCl5. What is the product? CH3COCl. Acid chloride. Okay, in the Arrhenius equation, when log K is plotted against 1 by T, very important question, Arrhenius equation question, what is its slope and intercept? Okay, so what is this Arrhenius formula? Arrhenius formula is K is equal to A e raised to minus EA by RT. Okay, taking logarithm on both sides, log K is equal to ln A minus EA by RT. Okay, in order to change it into what? In order to change it into logarithm, logarithm in terms of log K is equal to log A minus EA by 2.303 RT. Okay, now we are going to plot log K against 1 by T, log K and here 1 by T. Okay, so this is in the form of y equal to mx plus c, where m is the slope and c is the intercept, right? So in this case, what is the slope? Slope is equal to minus EA by 2.303 R. And intercept, what is intercept? Intercept is equal to log A. Okay, so this is a very important question. You must know the equations related to Arrhenius equation. And there is one more equation you have to study in this area. What is that equation? Equations relating log K2 by K1. What is that? EA by 2.303 R. Related to two different temperature. Okay, 2.303 R. T2 minus T1 by T1 T2. And one more thing you have to have, if you are asked to find the activation energy and if you are given the slope, which equation you will use? Minus 2.303 R times slope. Okay, so this is the equation we have to mention here. That is here in this case, you can see here, this is slope is equal to minus EA by 2.303 R. If you know the slope, you can find the activation energy. Okay, so different types of questions will be coming. Then assertion reason question. Separation of ZR and HF is difficult. ZR and HF have similar radii due to lanthanide contraction. That is the reason given. Very correct, right? ZR and HF. ZR belongs to 4D transition series and HF is belonging to 5D transition series, right? And they are belongs to same group but different periods. They have similar atomic radii because of this lanthanide contraction itself. Okay, that is due to the presence of F block element which is having similar size. Okay, and we call this as what? Chemical twins. Chemical twins because of the similar chemical properties. Okay, so assertion and reason are correct, and reason is the correct explanation for the assertion. Okay, next is pKa of ethanoic acid is lower than that of chloroethanoic acid, and reason is given that chlorine shows electron withdrawing effect which increases the acidic character of ethanoic acid. So ethanoic acid is CH3COOH. It is acidic, right? Yes, since it is an acid. And if there happens to come a chlorine in the place of hydrogen in ethanoic acid, chlorine act as a electron withdrawing group, minus I effect, right? So chlorine will abstract electrons towards itself. So hydrogen, release of hydrogen become more easy. So this is more acidic. Okay, so reason is correct. Now moving to the assertion, pKa of ethanoic acid is lower than that of chloro. So what is this pKa and acid strength related? Okay, that you have to mention. Okay, pKa lower means what? Stronger the acid. Stronger the acid. Okay, so here it is given pKa of ethanoic acid is lower. No, it is higher, right? This one's pKa will be what? This is stronger acid. Stronger acid is chloroethanoic acid. So this is stronger. So its pKa will be lower. Okay. So this statement is wrong. So assertion is wrong. Reason is correct. Next is aniline is stronger base than ammonia. So what is the structure of aniline? Aniline is NH2 and ammonia we know NH3, and both are having nitrogen atoms which is having a lone pair of electrons in that, right? Yes. Okay. Then unshared electron pair on nitrogen atom in aniline is become less available. So both are basic. Aniline and ammonia are basic due to the presence of lone pair of electrons on nitrogen atom of ammonia and aniline. And in the case of aniline, there is resonance structure. Okay. So this lone pair is become less available. So what will happen to its basicity? Less available means less basic, right? Basicity decreases. So this statement is very wrong. Okay, stronger base, not a stronger base. Ammonia is stronger base than aniline. Okay, that is the, so assertion is wrong, reason is correct. Next, which of the following does not show variable oxidation state? Which one does not show variable oxidation state? And in the case of iron, we have 26, right? 3D 5 4s 3D 6 4s2, right? And the case of copper 3D 10 4s1, and manganese 3D 5 4s2, and scandium, what is scandium? 3D1 4s2. Okay, so in out of this it is very clear that scandium does not show variable oxidation state. Why? Because we know that it achieves a stable electronic configuration by losing 3 electrons, right? So it will become scandium 3 plus. Okay, that is very stable because it will get a noble gas configuration by losing 3 electrons. Okay, yes. So scandium is a transition element, but it has only one unpaired electron in the d orbital, right? Yes. So if scandium loses 2 electrons, it will become unstable. Electron configuration becomes unstable. That is why it loses 3 electrons and becomes stable. Only this oxidation state is possible for this scandium. Okay. Next, the type of isomerism shown by complex COECl2 En2 plus. Is it ionization isomerism? When you go through the options, it is very clear, right? It is not ionization isomerism. And what about linkage? There is nothing like ambidentate ligand, and there is no coordination isomers is also not possible. So which one is the answer? Geometrical isomers, right? So this can exist in, because 2Cl, right? So C2Cl group can exist in cis and trans isomers. So this is a geometrical isomerism. Okay, you can draw like CO, Cl, Cl both sides. Okay, then you will be getting cis form of this one. Okay, this is cis. Then in the case of CO, if Cl in opposite side, you will be getting what? It is clear, right? Whenever there is linkage isomerism, you can see some ambidentate ligands that can ligate to different donor atoms. Ionization isomerism also you can see there will be something that has to ionize. Okay, and coordination you can see 2 spheres. Okay, just go through that. Okay, yes. Okay, hope you get it. Thank you so much for watching, and if you enjoyed the video and found it helpful, please give the thumbs up and share it with your friends. Okay, don't forget it. And if you have any suggestions, you can leave a comment in the suggestion box. Okay, and subscribe our channel and click the bell icon so that you will never miss an update. So stay curious, keep learning. We will see you in the next video. Till then, bye. Thank you.